So first question, if Alice wishes to send Bob an encrypted message, what key does she use to encrypt the message? So another scenario, Alice wants to digitally sign the message that she sends to Bob. What key should she use to create the digital signature? What name is given to the random value added to a password in attempt to defeat rainbow table attack? Next question, which one of the following is not an attribute of hashing algorithm? Which one of the following cryptographic goals protect against the risks posed when a device is lost or stolen? Hello everyone and welcome back to 591 Labs videos, and this is the third video in the CISSP exam preparation. Thank you much for joining. Hope you've enjoyed the previous videos, and again welcome again for this new video about CISSP exam preparations. So for those of you who are new to 591 Labs, they are top training certification company on the eastern side, like in Hong Kong, China, Taiwan, and Singapore. The mission of the company is to provide and empower candidates with exceptional exam preparation experience, specifically for ISC² and some other vendor-specific cybersecurity certifications. So sit tight, hang on, and hopefully you're going to enjoy this video, and it's going to be very helpful for you for your preparation journey for the CISSP exam. So in this video, we are going to conquer domain 3 and answer some of the questions addressing security architecture and engineering in domain 3. And we're going to include some of the valuable and important tips and tricks that can help you to prepare and conquer the exam questions. All right, so beginning with the first question, remember that if you want to answer the questions on your own, you can still pause the video at any time, and then once you have your answer, you can resume the video so that you can see the correct answer together, and the explanation for it, of course, as well. So first question, if Alice wishes to send Bob an encrypted message, what key does she use to encrypt the message? Is it Alice public key, Alice private key, Bob public key, and Bob private key? If you'd like to think about it, pause, and then resume once you have your answer. So this is Alice, and this is Bob. Everyone has a private key and a public key. As well, private and public. So if Alice wants to encrypt the message so that only Bob would be able to decrypt it. So this is, of course, is using asymmetric encryption with the key pairs, as you can see here. And when we want to achieve confidentiality over unsecured network, because maybe there is an attacker here, Mallory, for example, who wants to eavesdrop on the connection in there. So of course, each key pair, when we encrypt with one key, we can decrypt with the other one. So the scenario will happen like this. Bob is going to send his public key to Alice. Maybe Mallory is going to take a copy as well. Alice is going to encrypt the message using Bob's public key. And then Alice is going to send the message over. Since the message was encrypted with Bob's public key, it has to be encrypted with Bob's private. Bob's private is always with Bob. He never shared the private key with anyone. If it is shared, it is compromised. So in this case, the attacker is not going to be able to decrypt the message. So we achieved confidentiality over unsecured network by encrypting the message by the recipient's public key. In this case, Bob's public key. So another actually scenario, Alice wants to digitally sign the message that she sends to Bob. What key should she use to create the digital signature? So referring to the previous question, in this case, Alice wants to let Bob believe that this message really came from her and not from another attacker trying to impersonate her. So in this case, Alice will have to encrypt the message with her private key, which should exist only with Alice. So when Bob receives this message and he has Alice's public key, this is Alice public, if he's able to decrypt the message using Alice public key, means that it was originally encrypted with her private, which should exist only with her. So in this case, Bob will verify that this message really came from Alice. So to achieve non-repudiation, Alice should encrypt the message using her private key. So that's the answer here for this gene right here. Question: what name is given to the random value added to a password in attempt to defeat rainbow table attack? Is it a hash? Is it a soul? Is it extended? Or is it a rebar? Alright, so let's first discuss what does it mean a rainbow table. So remember, when we actually save passwords, we save it in the form of hashes. Why? Because hashes are one-way functions. They are irreversible. So even if the attacker got hold of the database containing the username and passwords, it is not going to be able to reveal what were the original passwords used to is hashes. Because again, hashes are one-way functions. They are irreversible. So the attackers got smart about it, and they created something called the rainbow table, which is a very large table containing the passwords, the possible passwords, very large number of possible passwords, and their hash value. So when they actually steal a password from the database that is already cached, they will search for this hash in the rainbow table. If they find the match while searching in the rainbow table, then they will know what password was used to calculate this hash, hence they will know the real password of this specific key. So in order to conquer this methodology, we have included something called salting. Salting is simply some random characters to be added to the password to make it more complex so that it wouldn't be easier for attackers trying to find this password in a pre-computed rainbow table. So the answer for this one is B. Next question. Which one of the following is not an attribute of hashing algorithm? They require cryptographic keys. They are irreversible. It is difficult to find two messages with the same hash value. They take variable length input. So as we said, yes, hashes are one way. They are irreversible. It's going to be unique on the messages calculated on. So having two messages producing the same hash is very difficult. And they are calculated on variable input. You can calculate it on a few letters or 300 pages. But they do not require cryptographic keys. Cryptographic keys is for encrypting algorithms, which is reversible function. We can encrypt the message and decrypt the message. So the answer for this one is A. It does not include cryptographic keys. Which one of the following cryptographic goals protect against the risks posed when a device is lost or stolen? Is it non-repudiation? Is it authentication? Is it integrity? Or is it confidentiality? So when you lose a device, you're most concerned with the data on it. You don't want the attacker or the thief to reveal the valuable data, the valuable information that is available on your device. So we are mostly concerned here with confidentiality. This one poses the greatest risk with lost. That's why a lot of the security mechanism available is like doing or having remote wiping technology. If the device was stolen, we can remotely delete all the data on it in order to preserve the confidentiality of the data that included on this device before. Next question. What cryptographic principle stands behind the idea that cryptographic algorithms should be open to public inspection? Is it security through obscurity? Is it the Kerckhoff principle? Is it defense in depth? Or is it Heisenberg principle? So actually the answer for this one is B, the Kerckhoff principle. He said that cryptographic systems should be secure even if everything about the system is public knowledge except the keys. So it means that the attacker can know what cryptographic algorithm you're using, everything. But even if he doesn't have the key, even if he knows only this doesn't have the key, he shouldn't be able to decrypt the data quality of the data that is encrypted. So the answer for this one is B. Next question. Which one of the following components is used to assign classification to objects in a mandatory access control system? Is it a security label? Is it a token? Is it a descriptor or security capability? So the answer for this one is actually A, security label. Administrator and processes may attach security labels to objects that provide information about the object attributes. They are commonly used to apply classification in mandatory access control systems. Betty is concerned about the use of buffer overflow attacks against custom applications developed for use in her organization. What security control would provide the strongest defense against these attacks? Is it firewall? Is it intrusion detection system? Is it parameter checking or vulnerability scanning? So the answer for this one is actually C, parameter checking or input validation. This is used with applications to ensure that the input provided by the user to the application matches what was expected from the user. So the developers, they use parameter checking to make sure that the input does not exceed the expected length preventing buffer overflow attacks. So input validation and parameter checking, they are used to ensure and to prevent these types of attacks. Next question. In the ring protection model shown here, what ring contains the operating system kernel? Is it ring 0? Is it ring 1, 2, or 3? So the kernel lies within the central ring, which is ring 0. Conceptually, ring 1 contains other operating system components. Ring 2 is used for drivers and protocols. And the user-level programs and applications, they run at ring 3. Rings 0 through 2 run in privileged mode, while the ring 3 runs in user mode. It's important to note that many modern operating systems do not fully implement this mode. Which one of the following system assurance processes provide an independent third-party evaluation of a system's controls that may be trusted by many different organizations? Is it a certification? Is it a definition? Is it verification? Or is it an accreditation? So the answer for this one is actually C, verification. Verification process is similar to the certification process in that it validates security controls. But verification may go a step further by involving a third-party testing service and compiling results that may be trusted by many different organizations. Of course, when you do the test on yourself, it's less likely to be trusted by outsiders. But if a third party does the test on you, does the audit on you, it is most likely to be less biased and more trusted by outside entities. Accreditation is the act of management formally accepting and evaluating system, not evaluating the system itself. Next question. Harold is assessing the susceptibility of his environment to hardware failures and would like to identify the expected lifetime of a piece of hardware. What measure should he use for this? MTTR, MTTF, RTO, and MTO. If I say the abbreviations, you will know the answer right away. So I'm going to give you a minute to pause, and then I'm going to explain what these abbreviations mean. So the MTTR means mean time to repair. What would be the average repairing time if a problem happens? The MTTF stands for mean time to failure. What is the expected time until the first failure happens, which means the lifespan of the asset or the tool that we are using. So, of course, this one makes more sense to the question here, so be it the answer. RTO, which is recovery time objective. If a failure happens, what is the maximum or what is the downtime we can afford before resuming our systems? And MTO stands, it's just 3 words. The other one should be the RPO, recovery point objective, which means that how many data can we afford to lose if a problem happens? So again, the answer is B, mean time to failure, provide the average amount of time before a device of that particular specification fails. Next question. Gary is concerned about applying consistent security settings to many mobile devices used throughout his organization. What technology would best assist with this challenge? An MDM, an IPS, an IDS, or a SIM? So MDM stands for Mobile Device Management, the one that we've earlier. So of course, this one is providing consistent centralized interface for applying security configuration settings to mobile devices. So the answer for this one is actually A, Mobile Device Management Solution. All right, thank you so much for joining today's session. We hope you find the information informative and helpful. Remember, practice is critical. The more you practice, the more you're going to gain the mindset, and it's going to help you out with your exam. If you have any questions or concerns, please don't hesitate to contact us. We appreciate and look forward to seeing you in future classes, and have a great